So let S be definition. Let S be a set. A relation, which is I'm not going to define exactly. Just think of it as something that tells you information between two things, like being equal is a relation. Whatever. Don't worry about the precise definition. It doesn't matter. A relation is called an order on S. So there's two requirements. So I'm going to give you these two requirements, but I'm going to give you their names too because they come up a lot. There's the trichotomy requirement, which I have probably misspelled. At least my notes agree with my spelling. And the trichotomy requirement says this. If x and y are in S, then exactly one of the following holds. So exactly one, if you don't remember, it means one and only one, right? So like one has to hold and no other could hold. But one of the following holds, either x is less than y, x is equal to y, or y is, or I shouldn't say less than, but that's what it is. Alright? So this is saying you have an order on a set. If one of these holds for any pair of numbers, or any pair of things in the set, I shouldn't say numbers, and exactly one of them holds. So if you ever go into, I'm going to call it crazy math mostly because I know very little about it. You might learn about partially ordered set, well-ordered sets, totally ordered sets. This is actually sort of a totally ordered set. But for the sake of us, we're going to call this an ordered set. Or we're going to call this, an order. We say, so now I'm just doing this again notationally. S with an order is an ordered set, or S with something is an ordered set. And by that I mean, so I should probably underline the word. But by that I mean is if I have an order on S, I call this an ordered set. Alright? And the reason we do, I didn't put the second condition. I'm so stupid. This happens, but we will say S is an ordered set. Sorry, the other one is transitivity. This is exactly what it means. It means for x, y, z in S, if x is less than y, and let's say y is less than z, then that's exactly as you expect, x is less than z. So this trichotomy means there's three possibilities, and they divide every pair of numbers. One of these is true. Exactly one of these is true. Transitivity just means it behaves like you expect. Right? So now we say S with an order is an order. It's called an ordered set. Great. So now I'm going to ask you again, can you guys think of an ordered set? The integers. I like the integers. In fact, we can actually put the integers to the natural numbers. I'm going to take the natural numbers out just because of algebraic simplicity. But here's my question. These are ordered, but what's their order? I mean, you guys kind of know their order. This all makes sense, right? If I give you two integers, you can tell me one's bigger. If I give you two rational numbers, you can tell me which one's bigger, or if they're equal, right? So it's clear that they are ordered. The reason I'm asking what is their order is I want to make a very precise definition of it. And the order is simple. I would say x is less than y if y minus x is positive. Does that make sense? And that is the order. And if you think about it, that's exactly what we do. And in fact, it's sort of emphasizing something that's going to be a big deal throughout this class. And I've already kind of said it. It's hard to show like A is less than B. It's a lot easier to show B minus A is positive. Cool? I'll go, if I have enough time, I have 2 minutes. Sure, I'll show you one more example then. I brought one more just in case you guys wanted to show. I mean, here's another example if you want just an easy ordered set. If it comes up, I mean, I'm going to use these other ordered sets to mess with you. Let's say I give you the set A, B, C, and I tell you that A is less than B, B is less than C, and A is less than C. Is this ordered?
Yeah.
Yeah, this will work. So yeah, this is an ordered set. Let me give you one more example. And let's say I give you now, I know we haven't technically defined it, but let's think of the complex numbers. And let's say I take two numbers, A plus BI and C plus BI, and I know this is getting sloppy, I just don't want to write too much for that in a minute. Let's say I say if A plus BI is less than C plus DI if A is less than C. In terms of real numbers. Is this an ordered set? Is C, so maybe I'll call it that, C less than squiggle, an ordered set. What do you guys think? The bell's totally correct. You guys hit the stage till I give you the magical answer. What do you guys think? Is this ordered? So I'm saying if the real part of this is smaller than the real part of that, I say this is less than that. Is this an ordered set? Why not? What fails? There's two rules. Which one fails? Trichotomy is going to fail. Let me give you an example. I'll give you one. You guys could have come up with one. But 3 plus I and 3 plus 2I. Which one's bigger? Are they equal? It's not an ordered set. Okay, so I'll see you guys tomorrow at 10. Everyone should have the homework. Oh, right. I forgot to say this. I'm going to say it right now. I'm putting up a webpage tonight. math.berkeley.edu /iventura, like my email. If you don't, I'm putting it up tonight. It'll have the homework, but it's in the syllabus. So not much of importance there right now. But it'll be up tonight, and I'll announce it at the beginning of tomorrow's class. If you have any questions, feel free to ask me right now. Otherwise, I'll see you guys tomorrow. Wow, actually, pretty impressive. Solid that we put it right away.